So my name is Lyle Barner. I'm here from the Jet Propulsion Lab out in Pasadena. I work with the software quality organization out there, and I'm here to talk to you about a tool that we've been using called CAE Scrub. So what is CAE Scrub? First of all, I'll start and say that the acronym is not great. It's very ambiguous. It doesn't really mean much. It's a mouthful. But the one important part to note about that is the CAE portion of it is Computer Aided Engineering Group. So that's another organization within JPL that basically just maintains all the institutional level tools that we use. So at a high level, Scrub is a tool for integrating your peer reviews or integrating static analysis results into your peer reviews. So essentially you are taking all of the warnings that are generated by different static analysis tools and using that to initialize a peer review and basically integrate those into the peer review process. The name Gerard Holtzman was tossed out yesterday during the autonomy panel, I believe. He was the original developer of Scrub, the lead of JPL's Laboratory for Reliable Software. He has since retired, so maintenance and development of Scrub has been passed to CAE now. Like I mentioned, I'm part of the software quality organization, but I'm working for CAE as the new lead developer, maintainer of Scrub. Scrub has been used by a ton of projects in the past at JPL. I think it has a heritage of about 10 years now. There's projects that are currently using it, and there's no shortage of people that are asking for it for their upcoming projects. We basically have a baseline version of the tool that's available for the projects to use that they can then configure and use however they see fit for their needs. So the value of Scrub. Oh, I should mention one more thing. I'm going to refer to it as Scrub just because it rolls off the tongue a little easier. Scrub and CAE Scrub are interchangeable terms. They both mean the same thing. They both refer to the same thing. So the value of Scrub. It helps you to basically organize and guide your code review process. So like I mentioned, you're taking those results from your static analyzers and folding that into your peer reviews that you are conducting throughout the development of your software. Scrub is composed of two parts. There's a backend that basically initializes your peer review, runs a static analysis, and then there's a simple dashboard GUI front end that you can use to basically view everything and go through and disposition your warnings. So like I mentioned, Scrub aggregates everything into one spot. So through that dashboard, you can review your source code, you can review the warnings. Basically, it just puts everything in a nice, convenient location for you to conduct your peer review. Another nice thing that it does through that GUI is it collects a log of all the information that's been captured through your peer review. So this is a list of all your warnings, all the comments from your human peer reviewers that are coming in, what they're saying about those warnings, results, whether you're finding things like false positives from your static analysis. That's all captured in the form of a log within Scrub. The intent here is to allow the developers to focus on some of the more abstract problems that can be found in your code and let the static analysis get you the 100% coverage and check things like compliance with coding standards and things like that would be better checked in an automated fashion. So the overall objective is to kind of combine the two worlds of static analysis and your human peer reviews. So you're getting the coverage of the static analysis and you're getting the in-depth thought of the human peer reviewer. So kind of the core concept behind Scrub is you're creating a peer review and you're essentially treating your static analyzers as peers in the sense that they can contribute warnings to this review process. So a basic overview of how Scrub works. The user provides a bunch of configuration information to Scrub to describe aspects of the source code and how the static analyzer should be run. They also provide information about what warnings can be ignored. So say you are looking at a particular module in your source code, you don't want to see warnings for anything else. You can basically focus Scrub in to only show you warnings for that particular module So you have areas that are dedicated to test scripts. You can also exclude those too, because you may not necessarily be concerned about the static analysis of those pieces of code. There is a standardized warning format that Scrub has. So essentially, you're taking information from all these different sources that display things in different ways, but basically contain the same core sets of information. So Scrub creates a standardized format so that everything in the GUI looks the same. All the warnings are just displayed in a standardized fashion. Then you can use the GUI front end to basically go through everything, agree, disagree, discuss all the issues that have been found, and capture that all in the log that I mentioned. And then finally, the lead developer can sit down, go through the log, and basically make an educated decision about every warning that was found through the course of the peer review. I won't go too in-depth into this, but this is basically just an overview of what that standardization looks like. We have a bunch of pieces of information. Basically, there's post-processing done in Scrub to convert everything to this format so that everything just looks nice and consistent. The main important part from this is that location piece. So that allows you to basically link directly to the exact location in the source code that the warning is referring to give you a little more contextual information about what's going on. So a little bit more on the evolution of this tool. Like I mentioned, it was originally developed by Gerard Holtzman. When he originally created it, it was for a single project, and it kind of took off from there. It had very wide adoption throughout JPL, and it kind of spread like wildfire as people started to use it and really started to like integrating it into their development. That was great, but it led to some problems because when it was developed, it didn't go through the typical rigor that a software development tool should have gone through. So there were some basic things that were just missing. So whenever I took it over, which was probably about a year ago at this point, I spent a lot of my time refactoring that back end. Since it had such wide adoption, we wanted to keep the look and feel consistent, so we didn't really spend a lot of time on the GUI. We spent more time kind of improving that back end. I did things like make changes to the architecture to make it more extensible, make it more stable. I improved the setup process to move it to a configuration file base to kind of abstract it and make it more generic and easier to deploy. We improved the error handling capabilities so that Scrub wasn't just silently failing and not giving the user any information about what was going wrong. Things like an installation guide and a user guide. Just things that someone coming in fresh trying to use Scrub, they would have all the tools they need to be able to use it properly. And then finally, it was transitioned into Git for our code management. So Scrub was kind of existing on lab without any formal CM process that it was using. So now we've moved it to Git so that every project has a consistent starting point that they can use for Scrub, and then we can also back up their particular deployment so that if something goes wrong and they need to redeploy, we can do that quickly and easily. And going from the other direction, if they develop something new and interesting for Scrub, we can easily pull that back into the baseline to get out to future versions. So I know this slide says architecture, but it's more of a kind of an interaction diagram of what's going on between the different parts and pieces of Scrub. So here we have the three initial pieces you need to get started: the source code, your static analyzers that you want to use, and your actual installation of Scrub. The installation of Scrub actually uses that configuration information supplied by the user to make the calls to the static analyzers and get them to look at the source code. The static analyzers are then looking at your source code, pulling warnings out of that. That in turn is generating some of those output files, basically all the warnings that were found by the static analysis. And then finally we have the GUI, which reads both your source code and your warnings to give you that information that you need to make a decision about the warnings. Finally, this is all currently lives on a single development machine. So we're looking at ways to make this distributed and kind of break it out in a way that is more user-friendly. But right now, you basically have to have access to a single machine that can hold all of this information. So slightly different look. This is a program flow for the back end of Scrub and how it runs and sets up your peer review. So first the user will initiate a run. They'll make a call to Scrub, say they want to kick it off, get some static analysis, and prepare for the human peer review. Scrub will initiate itself using that configuration information passed in by the user. It will make the call to the analyzer. The analyzer will perform a build and analyze the code. That will in turn create some output files. Those output files are then post-processed by Scrub into that common standardized format that it uses. And then Scrub will actually clean the build. Some of the static analyzers have to actually compile the code to perform their analysis. So we clean it after it's been performed just to ensure that everything has a common starting point. Then we get to our decision point. If there's more analyzers, we loop back up, repeat that whole process again until we've made it through all our analysis. At this point, you have initialized your peer review and you can perform that human part of the peer review. So here we have a typical usage example for what happens after you've run that back-end portion. You're ready to begin your human peer review. So it starts off running Scrub on your desired revision or branch of the source code, like I mentioned. That can be done manually or through system automation. Basically, anything that's capable of kicking off a bash script can run Scrub. Your peer reviewers are notified that they have new results that they need to go through. This can be through automation again or a manual process. Reviewers will then go through the static analysis results, make determinations on those. They can agree, disagree, discuss those things. They can also generically comment on the source code. So if they find something interesting that wasn't caught by the static analysis, they can also add that to the review and get that into the discussion as well. And that the important point with this is that can all be done asynchronously. So people can go through this set of results on their own time and discuss things asynchronously without having to have everyone sit down in a room and find, carve out time in people's schedule to get everyone sitting down together. Once everyone's had a chance to go through the code and the results, the lead developer can basically look at those log files and start making some decisions about what changes, if any, need to be made to their code. So if you have some warnings that are appearing that everyone seems to think are no-brainers, either it's an obvious false positive or it's something that's an obvious error in the code that needs to be fixed, the developer can note those and they can make changes. No further discussion is required. So the idea is to basically narrow down your peer review to the items that are only hotly discussed. Maybe a solution is not readily apparent. And then you get to point 5, where if you have a case like that where you need to actually get everyone in a room together to discuss, now you are much more focused onto the items that everyone thinks need to be discussed. Again, I won't spend too much time on this, but this is basically just an overview of what the GUI looks like. You have the warning browser, which allows you to look through all the warnings. The blue portion of that is actually the link to the code, so it will take you to the exact spot in the code where the warning is referring to, so that you can then make a decision. At the top right there, we have what the decision box looks like. You can agree, disagree, or comment. And then at the bottom right, we have the generic warning input. So this is, if a person finds something that wasn't already addressed, they can call that out and they can assign it a priority ranking. So like every tool, there's some things that Scrub does well. There's some things it does not so well. We'll talk about what it does well first. So it does a good job of providing a framework for integrating all your static analysis and peer review comments into one centralized place. So it basically is just a nice way of having everything you need to conduct your peer review and give you a way to systematically address all the warnings that were found by your static analysis. It does a good job of providing a standardization of your error types. So like I said, most of these warnings contain a lot of overlapping information, so Scrub just does Scrub calls out a specific format that is used to display that information that's easy to understand for everyone. It seeks to streamline your static analysis review process. So by getting all the obvious yeses and nos out of the way up front, you can then better focus your discussion onto the trickier design issues that are coming up. And finally, it helps to implement a repeatable review process that can be integrated into your development lifecycle. So, like I said, you can kick this off manually, you can kick it off in an automated fashion. It just gives you a repeatable way to conduct these kind of peer reviews that you can use throughout your development. So the areas for improvement. It's still kind of tricky to deploy, and it's kind of right now it's not really Scrub that's tricky to deploy, it's the static analyzers themselves. Some of them are easy, some of them have some quirks, but right now it's kind of not a trivial process. It originally was in Scrub to set up these tools, but that kind of tied you to a specific implementation of the tool. So we backed off from that, made it more abstract to give it a little looser coupling so that the teams can kind of set up the static analysis tools how they want them to be set up so that it works best for them. But it's kind of a trade-off now because the setup is a little more difficult. We currently don't have any integration with CM tools. So I know Scrub is in Git, but this refers to your actual source code that you're examining. So if you're using Git or SVN, you have to have a detached version of the code available. You can't just pass it credentials to go in and check that out. It's not too big of an issue, but it's just a little bit of a pain that's in that automation part of setting up your review for now. Quite frankly, the number of warnings that come out of Scrub can be pretty overwhelming. So depending on the size of your module and how you have your static analyzing tools set up, you're talking potentially thousands of warnings that are coming out. And if your team is not prepared for that, you may have to prioritize. It just can be difficult if you don't have it set up properly and you're not expecting the number of warnings that are coming out. The quality of the results is highly dependent upon your configuration. So how you have those static analyzers set up is going to basically determine the quality of the results that you're seeing. So there's some queries that aren't particularly applicable to the context of flight software development. So these kind of things, you may get a lot of noise in your output. So you just want to make sure that you have that kind of tailored to the specific problems that you're trying to find. And then finally, there's no severity ranking information for the static analysis. So all the priority by default for static analysis warnings is set to low. It's basically, we have that field in there for future scope. So ideally, in the future, we would have some kind of ranking information so that you could find these high priority warnings and address those first and make sure that those are taken care of. So the path forward for Scrub. One of our top priorities is to investigate integration with other code review tools. So anything, the GUI that exists for Scrub right now is kind of basic. It's written in TickleTK. It doesn't have a lot of functionality. So we've been investigating, potentially porting the warnings out from Scrub and basically conducting the peer review in a commercially available tool. This would be nice because then you can have Scrub running on a machine that's basically transparent to the user. They just care about reviewing those warnings. So you could have that in a web-based fashion, basically just something that's a little bit nicer, has a little more functionality, is a little more easy to deal with. We'd like to create a baseline set of queries for each of the static analyzers. So there's kind of a default set that comes from each vendor, but again, that's not really always applicable to flight software development. Ideally, we would go through all of this and basically define a baseline set of queries that should be run for each set of analysis in case the teams don't know where to start on that. Like I mentioned, we would like to create a ranking system for each of the types of warnings that are coming out, basically a way to prioritize when you do have a large number of warnings that are coming out. Stability improvements on the back end, it's pretty good right now, but text parsing is not an exact science for me. So there's still some room for improvement there. And then finally, a customizable query list for your static analysis tools. And what this means is, as it stands now for Scrub, you have one set of configuration for your static analysis per installation of Scrub. So I'd like to break that out to the analysis level. So you can have an installation of Scrub and basically pass in your configuration for each analysis that you're running the sets of queries that you want to run. So say you have a module that you're particularly concerned about cybersecurity or something like that. You can customize your queries for that particular analysis. So in summary, Scrub is a tool that we're using internally at JPL for our static analysis and peer reviews that we're conducting. It creates an extensible framework that you can use for connecting with your different static analysis tools. Gives you a repeatable process that you can use to conduct your peer reviews. Extensive work has been done to make this suitable for large-scale deployment, so something that we can deploy lab-wide to any team that wants it. And then going forward, we're looking to integrate this better into our software development lifecycle and the suite of tools that are made available at JPL. I think that is my last slide. Any questions?
Looks like there are many.
Okay.
Good.
It looks like that is just for the C language, is that correct?
We have it for C and Java right now. We've done a lot more work on C. Java is primarily what we use for our ground software development. So we're kind of breaking into that, but yeah, primarily C.
Why do you use C?
Why do I use C?
Yeah, why do they use C? Yeah.
That's what the flight software projects use. So that the vast majority of the projects are using C, so that's what the tool supports.
Okay. You don't know why they use C. It's a very unreliable language.
Hi, I'm Steve Whittemore with Los Alamos National Laboratory. This is the first time I've seen a peer review done from a static analysis with comments and discussions after that. Typically, we use static analysis tools as part of the development process. So I commend the use of that. So I'm assuming that peer reviews, because I was thinking it would incorporate normal peer reviews with the static analysis, where you incorporate the static analysis as a peer. Is that totally outside of the scope of this tool, or is that, would this tool incorporate comments normal, like when you're looking at architectures, design,
No, yeah, so
requirements coverage, stuff like that?
That's actually exactly the intent. So Scrub is a tool. You can use Scrub without any static analysis being put in as just a generic way to conduct a peer review, have your reviewers go through the code, make comments. Like you said, the idea is to treat the static analysis as another source of peer input into that process.
So it's all integrated into this tool.
Right, yeah.
Okay, thank you.
Yep.
I just wanted to ask one question. You didn't use the word open source, and you did use the term that it was available for JPL use. Right. How available is this tool?
So we are looking at making it open source. Currently, it's just for internal JPL use.
Okay, thank you.
Yeah, maybe this was in the presentation, but so you have a server instance, and that's serving comments to clients so people can see each other's comments?
So the storage mechanism for Scrub now is very basic. It's just storing everything as a text file. And then the GUI basically populates everything based on what's in that text file, stores everything as a text file. That's something we haven't really touched because we're looking at making it more distributed. Right now, yeah, it's just pretty basic. So it's not a server in the sense that multiple people are accessing it. It's basically just one machine that everyone has to go to actually view the information.
Thank you.
Yeah, I wanted to ask which tools did you, maybe you mentioned it, but I did not catch it. Which tools did you integrate? Because I suppose it's not, it's not a generic tool, so you need to work on the back end to integrate certain tools.
Right, yeah. So we've done some work to make that as generic as possible so that you can incorporate new tools. We at JPL, I think we currently use Coverity, Semel, and Code Sonar. This also has support for SonarCube, which is another open source one. Those are kind of the main 4 that we have right now. But to incorporate a new one, all you have to do is write some code to describe how you make the calls to the analyzer, and write some code to post-process the output to the common format. If you can do those 2 things, you can incorporate a new analyzer.
So I had one. I actually had the same kind of question, but then I had another one. If you go through the review, the results, decide to make fixes, whatever, based on all this, generate a new version of code, then are the results somehow able to be carried forward to the new version? How is that done?
It's not currently in the scope, but it's something that we're looking at because that traceability is important to make sure that you're addressing everything. But yeah, it's a good point. It's something we're looking at going forward.
Okay, I have a real simple one.
Sure.
As you discuss your changes to Scrub, are you using Scrub?
Actually, yes. Yeah, so Scrub is eating its own dog food on that one.
Good.
Excuse me. In your last slide, you talk about to compare the usage of Scrub with commercial tools, right?
So Scrub actually incorporates the tools into its analysis. So we.
Okay. No, it's because in our company we are using Garrett to do the peer review, the peer review itself, and it enables you to add all these static analysis to the review of the code, and also the testings of the code itself. So it seems like a very similar purpose tool as Garrett. I don't know if you're familiar with it.
We're looking at the options for replacing that front end, which I think that's what you're describing here. Garrett is one of the tools we looked at. SmartBear offers a product called Collaborator, which provides a similar set of functionality. We're going through that evaluation right now to kind of do exactly what you're saying. Provide a dashboard for kind of all of your code review needs so that it's in one centralized place.
Yeah, the main feature that I see in Garrett is the integration with Git itself.
Right.
So it's very easy to.
Yeah,
then
you buy some of that
reviews
functionality
and so
as well.
on and test the code on your machine.
Yeah.
Thank you.
So the CFS project board, change control board, has been using static analysis tools for their prior to release of a major release of CoreFlight software, and I think that this tool might be of interest to the CFS board. So if you want to work through a open source release, we'd be happy to guinea pig.
I think that is definitely what we're pushing for. So I think there's one more. Oh, he's got it.
Well, how about we send you to CFS code and you run it, and then give us the answers? Can we do that?
Yeah, I mean.
In your spare time, of course.
Yeah, my copious spare time.